All right, let's move on. So we've been talking about all of the different factors that affect climate. And again, as a quick review, we started with latitude, which has the most impact, the number one factor. Then we talked about elevation. We talked about the nearness to a large body of water. We talked about global winds. And now we're going to talk about ocean currents. Surface ocean currents. There is actually an entire page of your reference table dedicated to ocean currents. Okay, so an ocean current is basically just a river of water in the ocean, which is driven by the planetary wind belts. So actually the winds blow above on the surface, and they eventually cause the water to move. Okay, it's basically currents of water. We'll talk about it a little bit more in a minute. All right, looks something like this, but there is a much better picture. Here you go in your reference tables. And this picture is on page, I'll just turn to it myself. This is on page 4 of your reference tables. All right, and you can see that it is divided into warm currents, which are represented by a black arrow, and cool currents, which are represented by a white arrow. Notice, for the most part, the warm currents tend to come from the warm areas like the equator, and then they tend to go north or south away from the warm areas, bringing warm water with them to cooler areas. On the other hand, the cool currents tend to come from the polar regions, and they tend to bring cool water back towards the equator, like for instance right here with the Peru current or the California current. Okay, so we're going to use this. How do ocean currents influence the climate of an area? Well, this one's pretty straightforward. Warm ocean currents that pass by a coastal location will tend to make the area warmer. So if you live near a warm ocean current, your climate will be warmed by the warm water passing by. Okay. Now look right here. Can anyone tell what this is supposed to be? Probably not. It's a very strange picture, and I haven't said anything yet. This is thermal imaging of the east coast of the United States. Let me show you something. Okay, so that is the coastline. So this is Florida down here. You can see it jutting out. And that's New York. Okay, this over here is the ocean. And what I want you to notice, this orangey color and reddish orange, this is warm water that's coming up the coast of the United States. It shoots up and then it shoots off the coast. Now, if you look in your reference tables at the surface ocean currents page, you will see that there is a particular ocean current right over there. And why don't you take a second to take a look and see if you can figure out what that's called. So hopefully you're looking. Right? It's actually called the Gulf Stream current. And it's right there on page 4. It shows you. It brings warmer, wetter air to Western Europe and over near England. Okay? And here it is right over here. Right? That's a warm current bringing warm water, and therefore warming all the areas along the East Coast a little more than they would otherwise be if they did not have a warm current there. Okay? Now, a cool current does exactly the opposite. All right? A cool current are currents that pass by a coastal location and make the area cooler because they're carrying colder water. Okay? Now this is actually the west coast of the United States. Okay? This is a current that comes down the west coast and brings cold water down the coast, basically of California, and not surprisingly it is referred to as the California current. All right? And if you looked at I'm just going to go back. If you look at this diagram right here, you will see that the California current brings cold water from up north down here. So actually, if you were to go in the water over near San Francisco, the water is going to tend to be a little colder than it would be at the same latitude on the east coast, because the cold water makes the water colder. Pretty straightforward. Okay, let me just move back and forward to where we were. All right. This is just a little fun thing. I'll play it for you anyway. It's if you've ever seen Finding Nemo, he actually talks about a current. Let's see if you can figure it out.
Focus, dude. Dude. Oh, he lives. Hey, dude!
Oh, what happened?
Oh, I saw the whole thing, dude. First you were all like, whoa! And then we were like, whoa! And then you were like, whoa.
What are you talking about?
You, Mini-Man, taking on the jellies. You got serious thrill issues, dude.
Oh.
Awesome.
Oh, my stomach. Oh.
Oh, man. Hey, no hurling on the shell, dude, okay? Just waxed it.
So, Mr. Turtle.
Whoa, dude, Mr. Turtle is my father. Name's Crush.
Crush? Really? Okay, Crush. Listen, I need to get to the East Australian Current.
There it is.
EAC?
Oh, dude.
EAC.
You're riding it, dude! Check it out!
Obviously, this is an animation, but they are supposedly in the ocean current. Again, the current of water that's flowing through the ocean. Now, if you're actually watching this video and you want to email me the name of the East Australia Current and tell me exactly where it is in relation to the continent of Australia, I'm going to take note that you actually did that. So that's good. All right. This probably looks a little bit strange to you. This is another sort of little video. It talks about El Nino. You might have heard of El Nino. Okay, so for those of you that don't know what El Nino is, let me just play you this little clip.
I am El Nino. All other tropical storms must bow before El Nino. Yo soy El Nino. For those of you who don't habla español, El Nino is Spanish for the Nino.
Actually, that is not what El Nino is at all, but it is funny, and I usually like to show it in class. But let me move forward, okay? El Nino is a climactic event that occurs every so often when the winds that are normally blowing in one direction switch because of various conditions, all right? The winds are caused to switch from one direction to the other, and basically it messes up the weather, and it has serious consequences with the climate. Places that might normally be dry end up being stormy and wet. Places that might normally be wetter end up being dry, and it creates all kinds of issues, all right? So if you ever hear the term El Nino, it's referring to a climactic shift in the weather patterns, okay? It says a warming and reversal of the Peru current that changes worldwide weather patterns. Okay, usually when they ask a question about El Nino, they'll give a reading passage or something to help you along the way, or a diagram, much like the diagram you're seeing here. Okay, this is actually a really cool video. I'm going to try to play this for you through this. We'll see how it does. If it doesn't, I'll know in a minute.
You know the name? Now play the game. MTG Arena is your gateway to the CCG that stops.
Okay,
A natural force of nature unlike any other. El Nino is capable of unleashing a fury of climate changes and natural disasters that span from Alaska all the way to South America and beyond. What causes El Nino, and how are we affected by it? El Nino is not a storm, but rather a weather phenomenon in the Pacific Ocean. During an El Nino, the surface water temperature warms up, leading to complex weather patterns. South American fishermen in the 19th century, describing warmer waters during Christmas time, coined the name El Nino, Spanish for the Blessed Child. Nowadays, when sea surface temperatures in the equatorial Pacific Ocean rise 0.5 degrees Celsius over their historic average for 3 consecutive months, and once atmospheric conditions and rainfall patterns shift accordingly, scientists officially declare an El Nino. An El Nino event takes place about every 2 to 7 years. Normal east to west trade winds over the Pacific weaken, and warm water that normally travels westward is now moving toward the east. Moisture then rises into the air, and the effects of El Niño are felt throughout the Americas. In the ocean, warm water pushes colder water downward, blocking the important upwelling of nutrient-rich waters from the bottom. This causes some marine life to migrate to colder waters. Animals that normally feed on the sea life suffer, and fisheries throughout Central and South America suffer too. But El Niño's most noticeable repercussions are felt on land. In the western United States and Central and South America, the warm air and moisture lead to increased storms, rainfall, floods, loss of life and property, and the increase of some vector-borne diseases like malaria, even in places where they don't normally occur. In Southeast Asia and Australia, the opposite takes place. These areas suffer from drought, wildfires, and colder ocean waters. In 1997 and 1998, the world experienced the biggest El Niño in recorded history. Some estimates blame that El Niño for 2,100 deaths and $33 billion in damages. Mongolia saw temperatures reach 108 degrees Fahrenheit, there was record flooding in Peru, and the U.S. saw storms in the Gulf Coast, flash flooding from California to Mississippi, and tornadoes in Florida. Scientists are now better able to predict if and when an El Niño event will take place. This helps communities better prepare for the changes in weather patterns and better adapt to its repercussions.
All right. So that was El Niño. Now, guys, let me just focus. I don't want you to get overburdened or anxious about the amount of material that's being presented. So for this lesson, there's a couple of really important takeaways. One, you should be familiar with the ocean currents, page 4 of your Earth Science reference tables, which you don't need to memorize because it'll be right in front of you. A cool current tends to cool an area, and a warm current tends to warm an area. Very straightforward. El Niño is just basically a switch and a change in the climate and the weather caused by some complicated weather issues. So you don't really need to be overburdened with worrying about it other than to know that El Niño is related to climate and ocean current changes. You don't have to memorize that at all. Okay? So at this point, there are questions on page 13 and actually just page 13 of your notes. Questions 1 through 9, multiple choice questions. You really should try to answer these as best you can. And believe it or not, we are almost done with the factors that affect climate. All right? Good luck.